Hey there, I'm Sidhu. A couple of weeks back, I got invited to present at a Claude Code community event. And instead of presenting something boring like how I build my website, which I do all the time, or how I use Claude within my IDE, I wanted to do something insane. So I basically made Claude an aerospace engineer and it actually worked. So this was the first Pondicherry meetup in Pondicherry, and I was given probably like 10 minutes to talk, and this is what I basically told them. So Claude living in your IDE is actually restricting you from doing what you want to do. Claude inside systems of your industry unlocks a whole new potential. So what I mean is Claude is not actually meant to just be confined within your environment, within your IDE. The more tools, the more access, the more things you provide Claude, it gets better with actually doing all the difficult and hard work. This applies to mainly robotics, manufacturing, and other industries, which no one actually thinks about. And this is where the next billion-dollar company is going to be in. So let's say you're an aerospace engineer designing a defense project wing, right? And there is like 5,000 plus possibilities. You can tweak every small detail of the wing, and then you can run simulation, which is extremely computationally inefficient. It takes a lot of engineers, it takes a lot of time. So first of all, I want to discuss about how you can break this kind of complex system to something that an AI can understand. Fundamentally, I think there is only two things here. One is geometrical values, and then the simulation values or the calculations. And calculation is nothing but how well the output is from whatever geometric parameters that we define. So think of this as a input and output. Your input is geometry, and then your output is basically the coefficients and then all the calculations. So this is basically a mathematical model. This can be simulated with MATLAB. This can be simulated in different environments. You can run a CFD on SolidWorks or any platform can be used here. What I told Claude is, can we build the simulation ourselves? Does Claude has the ability to look at all these numbers, think of all the parameters, geometrical parameters, and then is it possible for Claude to make an optimal design? So that's the question I started with. Here is what Claude has built, and this is the design. This is basically the interface. I know this doesn't look very nice because this was built in probably a couple of hours, but I can zoom into the wing and I can see a pretty simple wing here, and I can change the sweep angle. This is the angle that's starting from the front all the way to the back. And then there is also different parameters that you can adjust. So here I can adjust height at different positions. So all of this is basically geometrical. So I just took x1, x2, x3, c1, c2, c3, and I'm able to adjust so many different aspects of the wing. So I can define the curvature, I can define the geometry and everything. And then what I can do is I am able to get a score on the top. So this is 9.88. I think the best performing one was something similar, 9.92. So this is 9.98, which is pretty good. And then I can run a simulation right in this environment. The best part is I don't have to manually adjust all these parameters. What we can do is we can also have Claude do it. So let me first show the simulation for you guys. I think the y-axis is pretty exaggerated in this case, but we can see how the particles and the flow happens around the wing. And we can also get very detailed CFD analysis here, bending momentum. So how much the wings tend to bend with different forces. And then you can see other details as well. And you can see all the life history here. So all the updates that you've previously gotten, all the scores that you have previously gotten, you can see here. So let me play this one more time and you can see pretty much the flow and everything. So how do we actually optimize from here, right? You can obviously run this 5,000 times until you get the best possible result, which is currently 9.92. Or you can also just tell Claude from the terminal, hey, Claude, can you just run the simulation from your terminal? Because Claude has access to your terminal. And then it can basically, this is all just JSON file. So everything that you see on the left side is a JSON file. And Claude can configure all this and then it can do 20, 30 runs. And the way Claude actually does this is having some kind of intuition. So instead of doing all the 5,000 possibilities, it's looking at what has performed, what could potentially perform, and then it's adjusting parameters based on that. So instead of doing 4,000, 5,000 runs of all the different possibilities, Claude is actually thinking like a human, and then it's giving us what is going to actually work. So I think that's where the power of Claude actually makes sense, because this is an LLM that can think like an engineer. And all of this is just built with Streamlit GUI, 3D Plotly, and then Arrow Sandbox, VLM. So the entire interface is a CLI and a prompt. So you basically tell Claude your problems. I prompted as if I know nothing about wings. So I prompted like a 5-year-old or a junior engineer. And then Claude was able to pretty much make the entire interface. So here is a wing optimizer CLI, and then I just tell what I want, and then it runs evaluation, it iterates intuitively to find better wings, and then saves the winner. This is where we unlock the true potential of Claude, where you have traditional computational systems and mathematical models, and then you have now language models. And when you put them together, that's when the magic happens, where you are able to just iterate so much more faster, where you are able to not just run randomly search all the parameters, but now you have also an intuitive model of how an aeroplane wing should look like, what has performed the best, and why we take certain decisions. So that's where the magic really happens, like I mentioned. So let me just walk you through the architecture. All of this entire code, the UI, the code, everything is just built by Claude. I had to simply prompt and it took 2 hours of my time. Another thing that I had to do is tell Claude, think of this in a two separate systems. One is your geometrical system and then your calculations. So here, from our simulation, we can see that we have score. We also have penalties and aspect ratios, and we have this lift to drag coefficient, which is what we are aiming to optimize the most. So that is the single most important number. And this calculation, which is lift to drag, is actually available in Google. You can just Google search that. I told this is a geometrical problem and then a physics problem. And what Claude is doing is it's segmenting the wing. So it's doing 16 parameters and then it's creating a 3D mesh. That is your left side panel. And second is you are able to simulate. So Claude is able to simulate from the terminal, and you're also able to simulate with a click of a button. And then the third is interface, one line JSON. So everything, the input is JSON, the output is JSON. So Claude is able to pick the next wing, not by randomly searching, but by actually looking at the numbers, looking at the inputs, and then finding correlation between the data. So what would take, 5,000 iterations of brute force, again, this is random search, so you can just do something like DE, and then it would just do randomly pick like all the available parameters that it can do under a certain limit. So instead of doing that, you have now gotten the best result, or 90% or 99% there. So just 20 iterations and you're able to get something that would take 5,000 iterations. So once I made the wing, I wanted to explore more options, like how can I apply the same pattern to a different physics. Then I thought about propellers. Propellers are extremely complex. They have so many parameters. There are so many things. Then I asked Claude, can we apply the same learnings that we had from wings into a propeller? And then I told, do all the research that you need to do to first geometrically define a propeller. So propeller has a bunch of formulas. So a propeller has a lot of definitions. So diameter, pitch, chord length, and then chamber, skew, and rake. If we can take all of this and let's define this as input, how can we start calculating the propeller efficiency? So a propeller efficiency there is also a score for that. And we can start taking all these formulas and then put it into a mathematical model, and we have something like this. So the same kind of UI, but now instead of simulating wings, I'm simulating propellers. So here again, I can change the RPM. Propeller has few more things, which is RPM and propeller's forward momentum. So if the propeller is traveling at a certain speed, how efficient is it at different speed? So here you can see that exact charts. So some propeller perform well at lower RPM, some propeller perform well at higher RPM. This is why you define the optimal parameters for propeller, and this is an extremely complicated problem to solve. So now I can simply click show the flow field, and I can see how much turbulence and how much air we are moving through. And then I can also change a lot of parameters, changing the twist or pitch or skew on the left side. So that would obviously decrease our efficiency here. So I can take the best propeller. So instead of baseline, I can take one of the test, and then I can see that it's 86% efficient. Or I can take a baseline and then I can load it, and I can see that it is 69% efficient. This way you're able to improve mechanical structure like a propeller across different ranges, and you can test them all by using AI. You don't have to even do the random search anymore for an extremely complicated part like propeller. So I'll just tell you exactly when this approach makes sense. If you're an established companies with decades of R&D and you have already spent like $1 million and produced like 50 different aircraft, this method doesn't make sense at all. The reason being, you already have all the expertise, and then you have learned so much from all the engineers. You have already done all the hard work where you don't need a system like this. But if you're starting a company from scratch, if you're a small startup, if you're a founder trying to build something amazing or crazy that no one else has thought about, that is so far apart from traditionally how the aircraft industries or any industry for that matter worked, this becomes your moat. This system took me 2 hours. For this system to actually run on a sustainable and scalable manner, this would take probably like 20 days or 30 days worth of R&D, so that you can do wings, you can do propellers, you can also calibrate your motors, you can calibrate your ECU, you can calibrate your flight controller, everything using Claude. But once you build this system, the rate at which you can iterate and rate at which you can scale or build products becomes so much different. The only bottleneck once you figure out the system would be your manufacturing capabilities, which is also much faster thanks to 3D printers right now. You can just iterate so much more faster, and then you can just build 3D printer items at scale right now. That is why I'm telling this system is huge, right? And you can be an early adopter and an early player with the system. So AI is powerful when it's systematic. Don't try to just not give context and then not have goals. Try to think of the systems that make your workflow much better. Try to think what you have done in the past, what you have learned by doing things in the past, take that system and then apply it into AI. Teach AI how you would do things. Or the most important thing that I would say is this input where I told Claude that you need to think of this as two separate systems. One is your geometrical system where we are able to use slider or we are able to think geometrical parameter. Then you have the simulation, which is all the calculation that you need to do. And then having Claude being able to interact with the web interface that I have. So I had to tell Claude, you need to think in this way in order for you to actually be successful with the project, because this is exactly what we did for the past 10-20 years, which is we make something mechanical and then we go and then we simulate and then we write down all the numbers and then we go and iterate again in SolidWorks. So I have a lot of experience with SolidWorks. I was a mechanical engineer and I used to build engine intake for student Formula Barrel cars. So during that time, I had to do so much simulation to just get the turbulence high enough for our engine to run more optimal. And now that can be just done with Claude, and then it can build the simulator for you, and then it can run all the simulations for you. That is the beauty of actually bringing traditional systems and AI together. If you have any questions, just comment. If you enjoyed the videos, please give me a like and then share it with friends who are building products